Hi, this is Mr. Sanders, and we are going to go through lesson 12 in advance of our quiz on Friday. I'm recording this on Wednesday evening, and I'm going to ship it out so that you can look at it before class. That way, you'll be caught up. This is some complex stuff, and you'll be in a good position to know it. And so let's get started. Okay, what we're doing today is we're going to find unknown values in proportional relationships. And that's really what we've been doing already. A is to B, as C is to D, or two fractions with an equal sign in the center, and only one of the numerators or denominators is a variable. That's a proportion. And you can solve those proportions and understand those proportional relationships. So that's what we're doing here. Okay, no vocabulary. And here you have a right angled triangle, and it's a 3, 4, 5 triangle. It's a Pythagorean triple. And these are the plans for a vegetable garden. And we want to write at least 3 equivalent ratios or equations using the lengths from both the diagram and the full-size garden. Okay, so for the diagram, here's 3 to 4 to 5. 1 unit is 2.8 feet. Okay, so that would be 3 times 2.8, and 3 times 2.8 is 8.4. Let's get the pen over here. There we go. 3 times 2.8. Okay, well, this is 2.4, and this is 6, so the whole thing is 8.4. All right, I know that looks like a multiplying, but it's actually 8.4 feet. So we'll point that out. This pen is not working as well with this tablet at home. All right, so we can work out the other numbers as well, but in this review and in anticipation of doing this quickly, here are the answers. Okay, sample responses, 3 is to 4, 3 is to 4. You can also have 4 is to 3, and you can have 3 is to 5, and 4 is to 5. But these are just a few of the possible answers. 3 is to 4, 3 is to 5, 4 is to 5, 4 is to 3, 5 is to 3, 5 is to 4, and you would get these various values here. So we've got 3 is to 4, 4 is to 3, and then multiplying the pieces out, there's our 8.4 that we got before. The other unit is 14, so 5 is to 14, things like that. Okay, these are just figuring out proportions. And that's what we're going to do here. All right, now in class, I will hand out a sheet of 6 different triangles, and you're supposed to take a look at them and make comparisons, looking at the similarities, looking at what the scale factor is, and solving for the missing lengths. All right, these are the 6 shapes, and what you want to do is compare key parts of triangles and see if you have corresponding parts. That way you'll know which 2 go together. All right, here's the answer. And the solutions for the 6 sides of the 6 triangles. I'm doing this more quickly because you can stop the video and rewind. All right, quilting questions. Here is a quilt design made of right isosceles triangles. The smallest squares in the center have an area of 1 square unit. So this has an area of 1 square unit. And the only way you can get that is if the sides are 1. 1 times 1, right, is 1. So there you go. That would be 1 square unit. You're supposed to then find the dimensions of the triangles. So if we know that this is 1, and that's 1, and this is 1, and this is 1, we can start to figure out the other parts and what the dimensions are of these triangles. Now remember, the basic parts of the Pythagorean theorem are that, let me write it down. We'll go over here. Again, this pen is being tricky. A squared plus B squared is equal to C squared. And here we have 1 squared plus 1 squared is equal to C squared. Well, 1 squared is 1 and 1 squared is 1. So this is 2 is equal to C squared. Well, we need the value of C, not the value of C squared, so we have to take the square root. And when we take the square root, we do it on both sides. And what we get under the square root symbol here for C squared is we get C, which is what we want, and it's equal to the square root of 2. All right, that's going to show up in various locations here as we go through this. And then the other questions are the triangles similar? If so, what are the scale factors? And then we have a proportion set up. Let's take a look at the answers. So you can see it's a little more tricky. I isolated the quilt design, and then I did some calculations, and this is what I got. And as I went through, I made a mistake out at this level, so I've corrected it here for you to see the lengths for everything. Okay, and then the final, these are the answers here, and you can review those at your leisure. All right, now, are you ready for more? Here's a quilt design made with right triangles. Find as many right triangles. No, it doesn't say right triangles. It says find as many different size triangles as you can. That means we can take right triangles by themselves and combine them and all that, and then write similarity statements for the 2 pairs of triangles. And then again, here's a proportion setup. Now, there are certainly more triangles here than you can see at first glance, but what I did is I said, well, this is symmetrical, so I'm going to set up this line of symmetry, which means that on one side, I'll have as many triangles as on the other side, so I can just count up one side and deal with that first. Then I'll have to deal with other things. So let's take a look. All right, first thing I did was I counted up the right triangles on the left-hand side. So 1 there, 2, 3, 4, 5, 6, 7, 8, 9 right triangles. Then, as you can see, I've marked with the markers other triangles on this side. So I have 1 here, 1 here, 1 here, and 1 here. And that's the 4 that I have, and I marked those as numbers 10, 11, 12, and 13. Then I looked again, and I saw here a right triangle that goes across. It incorporates the smaller triangles 2, 3, 4, and 5. So it's right there. And then there's another one down here, incorporating 6, 7, 8, and 9. And that's my 14 and 15. And then there's one big triangle right here that incorporates all of these triangles other than triangle number 1. So there are 2 of those. Let's see. I'm sorry. There's 1 of those. So that's triangle 16. Times 2 for both sides, that gives me 32 triangles if I just look at the triangles on the left and then reflect them across. But there are other triangles as well. The other triangles are the triangles that incorporate both sides. and traverse this axis of symmetry. And so there's one here, one there, one here, one there. That's 4. And then the two big ones, 1, 2, gives me plus the 32 from before. I get 38 triangles in total this way. But what did I get? Let's take a look. Yes, incorporating both sides, I got 32 triangles. And then adding these last 6 gives me 38 triangles in total. Okay, that's a summary. Here is the summary of the lesson. That wraps up that part. The next thing is to look at the cool down, and I'll handle that in a separate video. Thanks for watching.